Hi, this is Ramachandran from onlinemathfora.com. In this video, we are going to see how to redefine an absolute value function as piecewise function, part 2. Okay, now I'm just going to consider a function that is f of x is equal to absolute value of x positive, absolute value of x negative 2. I'm just going to consider this function. So this is an absolute value function. Now I'm going to show you how this absolute value function can be redefined as a piecewise function. So here we have two absolute values on the right side. One is the absolute value of x and absolute value of x negative 2. So whenever we are trying to redefine absolute value function as piecewise function, so first we have to find the value of x, so for which the term inside the absolute value becomes 0. So here we have two absolute values. So first let us do it one by one. So first let me consider the first absolute value, that is absolute value of x. Now I have to find the value of x for which the term inside the absolute value becomes 0. So for this one it's very simple, because we just have x inside the absolute value. So if we want it to be 0, we just have to take x is equal to 0. So so if we want the term to be 0, if we want the term inside the absolute value to be 0, so we have to find the value of x for which the term is going to be 0. So here x is equal to 0. So for this value the term inside the first absolute value becomes 0 when I take x is equal to 0. So the same thing I have to do for the second absolute value. So in the second absolute value we have the term x negative 2. So here we have to find the value of x for which x negative 2 becomes 0. So it's very simple, x is equal to 2. So if I take x is equal to 2 in the second absolute value, so it will be 2 negative 2, it will become 0. So for any absolute value function, if we want to redefine as piecewise function, so this is the first thing we have to do, that is we just have to find the value of x for which the term inside the absolute value becomes 0. In case you have two absolute value, so you have to find two values for x, so for which each absolute value becomes 0. So here we have two absolute value in our function. So the first absolute value, the term in the first absolute value becomes 0 for x is equal to 0. So the term x negative 2 in the second absolute value becomes 0 for x is equal to 2. So in this way, first we have to find the two values for x. So for any absolute value function, so when we are trying to convert into piecewise function, so after getting these two values, now we have to mark these two values on the number line, on the real number line. 1 second. So now I am going to mark these two values on the real number line. So 0, so 0, 2. So when I mark these two values 0 and 2 on the real number line, so I get three intervals. So this is one interval, so this is one interval, so this is one interval. So less than 0 is one interval, so between 0 and 2 one interval, so greater than 2 is one interval. So less than 0 means we are going to take values for x less than 0, so that is x less than 0 here. And here we are going to take the value of x between 0 and 2, that is 0 less than x less than 2. And here the value of x is going to be greater than 2. In this way we are trying to get three intervals, x less than 0, so 0 less than x less than 2, that is the value of x is going to be between 0 and 2, and the third interval is x greater than 2. So now we have five conditions. So the first condition is x is equal to 0, the second one is x is equal to 2, so the third one is x less than 0, the fourth one is 0 less than x less than 2, and the last one is x greater than 2. So now we have to see what is the result of f of x for each of these conditions. So if I take the first condition, x is equal to 0, so what result do we get for f of x? And then I'll take the second condition, x is equal to 2. So for x is equal to 2, so what result do I get for f of x. In this way I have to get result for f of x for all these 5 conditions. So okay, I'll just continue the next step on the next page. So 1 second. Okay, now we have the function. 1 second. F of x is equal to absolute value of x positive absolute value of x negative 2. This is the function we have. Now I'm just going to take the first condition, that is x is equal to 0. So now let us see what happens to f of x if x is equal to 0. So f of x is equal to, since x is equal to 0, absolute value of 0 will be 0, positive absolute value of 0 negative 2. So absolute value of 0 will be 0, positive absolute value of negative 2. So f of x is equal to, so 0, we don't have to consider this 0, so absolute value of negative 2 will be positive 2. So we get f of x is equal to 2 for x is equal to 0. Okay, now I'm just going to take the second condition, that is x is equal to 2. Now let us see what is the result of f of x if x is equal to 2. So if I take x is equal to 2, absolute value of 2, positive absolute value of 2, negative 2. So absolute value of x is equal to simply 2, positive 2 negative 2 will become 0, absolute value of 0 will be 0. So f of x is equal to 2. So this one we get, we get the result f of x equal to 2 for x is equal to 2. So here we get the same result for f of x for both x is equal to 0 and x is equal to 2. So for these two conditions we get the same result. So now I'm going to consider the third condition, which is x less than 0. So f of x is equal to, so now we have to be a bit careful. 1 second, sorry. So I'm just going to take the condition x less than 0, f of x is equal to, so if x is less than 0, what happens to the term inside the absolute value? So first let us consider the first absolute value, which is the absolute value of x. If x less than 0, so what is the sign of the term inside the absolute value? So we have only x in the first absolute value. If x is less than 0, clearly its value is negative. Since its value is negative, we take the term inside the absolute value with a negative sign. So it will be negative x. And here we should not take like absolute value like this. So only if we take exact value for x, we take along with the absolute value. So like x is equal to 0, x is equal to 2. Since x is exactly equal to 0, so here we take along with the absolute sign. Here, because here we take x is equal to 2, exactly 2. So only if we take exact value for x, we have to take along with the absolute value. Otherwise we just have to take along with the sign. So here when x is less than 0, so the value the sign of the term inside the first absolute value is negative, because we just have x in the first absolute value. So if x is less than 0, its sign will be negative. So I take the term inside the absolute value with negative sign, so that is negative x. Okay, so the same condition is applied for the second absolute value, that is x less than 0. If x is less than 0, so this value will be negative. Already we have negative 2. So when we simplify negative value and negative value, that means when we add negative value and negative value, so the result will be again negative value. So for x less than 0, the term inside the second absolute value is also negative. Since its value is negative, we take the term inside the second absolute value with negative sign. So negative of x negative 2. I hope now the students would be able to understand why I take negative sign. So for x less than 0, so the term inside the first absolute value is negative, so I take the term with negative sign. So for the same condition x less than 0, so the term inside the second absolute value is also negative, so I take the term in the second absolute value with negative. So we get f of x is equal to negative x. If I multiply negative sign inside the parenthesis it will be negative x. Negative times negative will become positive 2. So f of x is equal to 2 negative x, negative x will become negative 2x. So we get the result f of x equal to 2 negative 2x. So for the condition x less than 0. Okay, now I am going to consider the third condition, that is so here the x is going to be between 0 and 2. So 0 less than x less than 2. So here the value of x is going to be between 0 and 2. So if we consider the first absolute value, the term inside we have the absolute value is x. So here we are going to take the value for x is between 0 and 2. So any value between 0 and positive 2 will be positive. So the same value is going to be applied for the term x. In case we are going to take 1 which is between 0 and 2, so the same one is applied in the first absolute value, the value will be 1, so it's positive. So whatever value between 0 and 2 we take for x and apply in the first absolute value, so its sign will be positive. Since its sign will be positive, so we take the term inside the absolute value as it is. Here I don't take negative x, but here I take negative x. So the reason is, for x less than 0 the value of the term inside the absolute value is negative, so I took negative x. But here for 0 less than x less than 2 the value of the term inside the absolute value is positive, so I just take the term as it is. Okay, now for the same condition, let us check the sign of the term in the second absolute value. So here the condition is the value of x must be between 0 and 2. So if I take any value between 0 and 2 in the second absolute value, so x will be less than 2, because important condition is x has to be greater than 0, at the same time x has to be less than 2. So when x is less than 2 here, it will be smaller number, it will be larger number. So here we subtract larger from smaller, so definitely its sign is negative, because whenever we subtract larger number from smaller number, its sign will be negative. Since the value of the term inside the second absolute value is negative, so we take the term with negative sign, so negative of x negative 2. So students, please don't get confused. So here for the first one we don't take negative, for the second one we take negative. So the reason is, for the condition 0 less than x less than 2 the term in the first absolute value is positive, so we take positive x. But for the same condition 0 less than x less than 2, the term in the second absolute value is negative, so we take the term with negative sign. So if we simplify this one, f of x is equal to x, negative times x will be negative x, negative times negative will be positive 2, x will get cancelled, positive x negative x, so we get f of x is equal to positive 2 for for 0 less than x less than 2. So for I got the result for f of x for the four conditions: x is equal to 0, x is equal to 2, x less than 0, 0 less than x less than 2. I have to find result for f of x for one more condition, so that is x greater than 2, so that we can do it on the next page. So this time I am going to take x greater than 2. So if I take x greater than 2, let us see what happens to f of x. Okay, before we are going to take the condition, let me write the function again. So absolute value of x positive, absolute value of x negative 2, because we need the original function to check for the condition. So now this time I am going to take the condition x greater than 2. Now let us see the result for f of x. If x is greater than 2, we can take any value greater than 2.134, something like that. All of them are positive values. So for the first absolute value, we have the term x. So if x is greater than 2, we can apply 3, 4, something like that for the first absolute value. So definitely its sign is going to be positive. Since the sign of the term inside the first absolute value is positive, just take x as it is. Okay, since x is greater than 2, we can take any value greater than 2 in the second absolute value also. So since x is greater than 2, so this value will be larger than this one, because the value of x is greater than 2 here. So this time 2, if it is greater than 2, it can be 3 or 4, something like that, but greater than 2. So this time it's going to be larger, it's going to be smaller. So here we subtract smaller from larger, so the sign will be positive. So since the sign is positive, we take the term inside the second absolute value as it is, x negative 2. So we get f of x is equal to 2x positive 2. So now I got result for all the condition. That is okay, 1 second, I'll just go back to the previous page. Please wait. Okay, so on this page we have result for f of x for 4 conditions. In this page we have to consider an important thing. So that is we get result 2 for f of x for 3 conditions: x is equal to 0, x is equal to 2, 0 less than x, less than 2. So for these 3 conditions we get the same result. So since we get the same result for these 3 conditions, we don't have to write these 3 conditions separately when we are trying to write the given absolute value function as piecewise function. So we can combine these 3 conditions into single condition. So how is it possible? Here we have a question. Here x is equal to 0, we get 2. X is equal to 2, we get 2. For x for 0 less than x less than 2, we get 2. So x is equal to 0 or x less than 0. So forget for both the conditions we have the same result. So x is equal to 0 or x is greater than 0. So it can be written as 0 less than or equal to x. So it means x can be equal to 0 or x can be greater than 0. And here, 1 second, x is equal to 2 or x less than 2. So it can be combined. X is equal to 2, we get the result f of x equal to 2. For x less than 2, we get the result f of x equal to 2. Already we know that x is greater than or equal to 0. So x is equal to 2 or x less than 2, we get the same result. So it can be written as x less than or equal to 2. So all the 3 conditions are combined into single condition, that is 0 less than or equal to x less than or equal to 2. So here x is equal to 0. So this condition is taken. If x is greater than 0, so this condition is taken. X is equal to 2, this one is taken. X less than 2, this one is taken. So we have considered all the conditions in a single condition, that is 0 less than or equal to x less than or equal to 2. So for all these 3 conditions we get the same result, f of x is equal to 2. So okay students, I'll just move to the next page. Now I am going to write the piecewise function. So for the given absolute value function, so f of x is equal to, we get 1 second, I just forgot the result for x is for x less than 0, we get 2 negative 2x. 2 negative 2x if x less than 0, and we get f of x is equal to 2 if 0 less than or equal to x less than or equal to 2, and we get 2x positive 2 if x greater than 2. So for this absolute value function, f of x is equal to absolute value of x positive, absolute value of x negative 2. We get the piecewise function, that is f of x is equal to 2 negative 2x if x less than 0, and we get the result f of x is equal to 2 if 0 less than or equal to x less than or equal to 2, and we get f of x equal to 2x positive 2 if x greater than 2. So now I hope the students will be able to understand so how a piecewise function can be how an absolute value function can be redefined as piecewise function. Okay students, for more videos like this please visit www.onlinemathforall.com. Thank you.